I'm going to wrap up chapter 4 now with doing some composition of trig and inverse trig functions. That are not multiples or with angles that are not multiples of pi over 4 or pi over 6, which means all of the special angles that we've been talking about, pi over 6, pi over 3, pi over 4, all of those multiples. We're not going to be talking about those angles right now, but we're still going to do a composition of like sine, cosine, tangent, and the arc sine, arc, cosine, arc, tangent. And I'll show you what I mean by that. Let's say we have to figure out what is the sine of the arc tan of 4/3, and all of this is with no calculator. So none of us know what the arc tan of 4/3 is. This is not one of our special angles that we always deal with, but we have to figure out what the sine of the angle whose tangent is 4/3. And so what we can do is, and you did this in Algebra 2 last year, what we're going to do is we're going to draw a right triangle. And we're going to fill in the missing side with the Pythagorean theorem. I'll just say use a squared plus b squared equals c squared to solve for the missing side. And then we're going to use SOHCAHTOA to figure out what that trig function is going to be evaluated as. So use SOHCAHTOA. Because it's a right triangle, we can use the Pythagorean theorem and SOHCAHTOA. If it was not a right triangle, we couldn't use either one of those. So what this means is if you're doing an arc tan of 4/3, we'll draw a little right triangle here. And we'll label this angle down here theta. Tangent is opposite over adjacent, so we have 4/3. So here's theta, the angle that we're talking about, the arc tangent of 4/3 is this angle theta. And this is just simply a 3, 4, 5 right triangle, so we don't even really have to use Pythagorean theorem because we already know this special right triangle. And what is the sine? We're asking for the sine of that value theta right here. And the sine of that is opposite over hypotenuse. So the sine of theta is equal to 4/5. So that would be the answer to this problem. And you probably remember doing a lot of that in both geometry and Algebra 2. But it wasn't probably written this way in the composition form. So we'll just do a couple more examples like this, and I think you'll probably catch on pretty fast, and we'll call it a day. The next one, let's do a cosine of the arc sine of 3/5. So we're going to draw our right triangle with theta down here. Sine is opposite over hypotenuse. So opposite over hypotenuse. Again, this is another 3, 4, 5 right triangle. And so we're actually finding the cosine of that angle theta down here. Cosine of theta is adjacent over hypotenuse. So we have 4/5. And that's the end of that. The only time it gets tricky is if we start getting negatives involved. So our next example will be a negative. Let's say we have to find the secant of the arc cosine of -12/13. If we have an arc cosine of a negative number, we know from yesterday that this angle is going to be in quadrant 2 because arc cosine the output only comes from quadrant 1 if it's positive and quadrant 2 if it's negative. So what I'm going to do about this right triangle is I'm going to just draw it in quadrant 2. So our angle is going to be theta over here. Cosine is adjacent over hypotenuse, so we have negative 12/13 adjacent over hypotenuse. And this is another one of our Pythagorean triples, a 5, 12, 13, or you could do a squared plus 12 squared equals 13 squared, and you could figure out that this missing side is 5. So right now we're doing the secant of this angle, theta. Secant is the reciprocal of the cosine. So since the cosine is negative 12/13, then the secant of this is negative 13/12. And we might have even been able to figure that out because secant and cosines are reciprocals of each other. So the output would be the reciprocal of that answer. But it's a good idea to go through this exercise to make sure. Let's do one that isn't one of the Pythagorean triples that we know. Let's evaluate the cosecant of the arc tan of 6/5. We've got a positive input value, so we can just draw a regular right triangle here, label theta here. Tangent is opposite over adjacent. So now we have to find the hypotenuse by doing, I'll call this C. I'll just say C squared is equal to 36 plus 25, A squared plus B squared. So C is equal to the square root of 61. I hope I did my math right. Cosecant is the reciprocal of the sine. So the cosecant is equal to the hypotenuse over the opposite. The hypotenuse is the square root of 61, and the opposite is 6. So the answer to this problem is the square root of 61 over 6. Let's start evaluating some more negatives. Let's say we have to find the cosine of the arc tan of negative 12/5. Well, the arctan of a negative number will be in a quadrant 4. It'll be a quadrant 4 angle. So like I did in the other example, I'm going to draw my right triangle right in quadrant 4 to take a look at what we have here. So here's our quadrant 4 angle. We'll call it theta. Tangent is opposite over adjacent, so the opposite side is negative 12 because it's going down, and the adjacent side is 5. So again, we have a 5, 12, 13 triangle. Hypotenuse, the hypotenuse is always positive, so I'll label that with a positive number. Now we have to find the cosine of that angle theta. All students take chemistry says that the cosine of this angle is going to be a positive number. Cosine is adjacent over hypotenuse, and we can already see that 5 and 13 are both positive numbers, so the cosine of that angle is 5/13. And we'll do one more example to wrap this up. Let's see, what haven't we done? We haven't done a cotangent yet. Let's do the cotangent of the arc sine of negative 7/8. Well, the arc sine, the output to arc sine will be in quadrant 4 because we've got a negative input, so this is another quadrant 4 angle, just like with arctan. If it was negative, it would be quadrant 4. So down here, I'll draw a quadrant 4 angle. Sine is opposite over hypotenuse, so the opposite is -7 and the hypotenuse is 8. And so we have to find this adjacent side here. So we can say a squared plus 49 is equal to 64. So a squared is equal to 15. So a is equal to the square root of 15. And since I'm finding cotangent of theta is equal to adjacent over opposite. So the adjacent over opposite is the square root of 15 over -7. So we'll just make that whole answer negative. And our final result is the square root of 15 over 7. If you happen to get a square root in the denominator of your fraction, you can go ahead and rationalize the denominator if you want. But I'm not a real big fan of rationalizing a denominator, so I don't think it's completely necessary to do that. So here's your final answer for that. Now hopefully I've allowed you enough time to go and study tonight, because you're going to have a quiz on all of the trig graphing topics that we've done since your last quiz, which is quite a bit. So please go over your notes, and maybe you want to rewatch another one of the videos that I've previously made. But please spend some time preparing for the quiz tomorrow.